Guys, Easy Science here. Studying for an exam or just learning for fun, you've come to the right place. Today's topic is visualizing the power rule. As you've seen in my previous video about derivatives, you learned what the power rule was. But the power rule is it's an easy thing to understand. Well, not to understand, but to remember and use. As you can see, just a quick reminder, this is the power rule. The derivative of f of x is equal to rx, r minus 1. So if it was something like x squared, it would equal 2 is r, so it would be 2x to the second minus 1 power, which would be 2x. Easy, right? But what does this mean? Where was this derived from? Okay, I'm going to explain this in a geometric way. I've explained in an algebraic way last video. I'll do a quick review on that this video. But I'll make you get a visual image in this video. First, let's do the algebraic way to get you on the roll to what this means. So algebraic method. So if we had, let's say, f of x is equal to x squared, we'll use the difference quotient, if you don't remember what that is. So right here is the difference quotient, and let's solve this algebraically. This is also as limit of h as it approaches 0. This basically means that with the derivative, it is a slight nudge, instantaneous change. So 1 is at h as it approaches 0, it doesn't become 0, it zooms in on 0, becomes infinitely small. So 0.0001, etc. But way smaller. You can't reach the smallest number. You approach 0. So, but if you plug in 0 to h, it's undefined. We have to solve it differently. So, okay, f of x is equal to x squared. So, x plus h squared minus x squared divided by h. What we did here is replace the f with our equation. This term is x, and this term is x. So we just squared both of those terms. So let's solve it now. As you know in last video, when on the a plus b, or whatever, squared equal to a squared plus 2ab 2ab plus b squared. So, let's do this. This is equal to x squared plus 2xh plus h squared minus x squared divided by h. Okay, we got it. We have the start. Now, let's minus x squared plus x squared is equal to 0. These cancel out and become 0. What we're left with is 2xh plus h squared divided by h. What does this mean? Let's factor a term out. We can see there are two h's in the top, divided by a plus sign. So we could factor out an h. H multiplied by 2x plus h, like this term, 2x plus h multiplied by h, divided by h. Since h and h cancel out, we're left with 2x plus h. But why is there still an h if the equation doesn't have an h? Well, this is where it comes in. As limit one second, as limit of h approaches 0 of 2x plus h. With our limit properties, we could plug in 0 into h, which would be equal to 2x plus 0, which is ultimately 2x, derivative of x squared. I will show you this using a graphic method, visual method. Okay, just keep that there, and keep so let's imagine x squared. We have our function x squared, with x being side length. This is basically x squared visualized. A square. Exactly what x squared is. X multiplied by x to make a square. So we made a small budge of dx. Let me represent that. Made a small budge of dx on both sides, which by means created two rectangles. So if the formula for the derivative of this in this situation would be df divided by dx, or dy divided by dx, whatever function you're using, df would be the slight nudge in area, since that is the instantaneous change, the small nudge of dx, which would be the two rectangles plus the small square they created. Right. Okay, and each one of these rectangles has side length of x and width of dx. With both of these, multiply by 2, or 2x multiplied by dx, since there's two rectangles. And dx is the slight nudge that was created. Let's say dx is 0.01. Very small nudge. So if it's 0.01 change, that is very negligible. So anything like that square that you added, maybe even a cube, anything with a power greater than 1, you could ignore. So we're just going to take that away. Take it away. So what this leaves us with would be two rectangles or leave us with 2x dx. So since we removed the small square, since we want the instantaneous change has to be as small as possible. So I'm just giving these fair width, but they could be as thin as lines, since it's instantaneous. That's what's supposed to happen. That means that dx would get so small it wouldn't even matter, or dx squared, the square that we removed. So what's left are these two rectangles, which really matters, which is 2x dx, and solving algebraically, divided by dx, df dx is equal to 2x, just like we solved algebraically. We just visualized it as a small change in area with two rectangles and removing the square added. So let's visualize x cubed, a harder thing. So let's say we have a cube, f of x is equal to x cubed. And we have an instantaneous change of, again, dx, sorry. So dx, which in turn adds another side here. It adds another cube face, actually 3 cube faces here, and here, or wherever you want, since we added a bit of area. And to fill in the top sides where it's missing is a rectangle, another rectangle, another rectangle. To fill in one of those spaces, we have one cube. So we have three faces plus three rectangles plus one small cube. Let's do the same process. If dx limit as dx as x approaches 0, they get infinitely small, which would mean the cube and the rectangles would be negligible and shouldn't be counted. So the only thing that would count would be these cube faces. Or as dx becomes infinitely small, instead of having width something like this, it could be even visualized as area, because it's so thin, infinitely small. Since it still has area, what's the so with side length x, since dx is so small, side length x, what's the area of a square? X squared. So basically right now we have 3x squared, just using those 3 extra areas that we got and applying their formulas. Okay, let's use the power rule just to check if I made any mistakes. So x squared, 3 is the r, which would be equal to 3x to the 3 minus 1, which is equal to 3x squared, proven by the power rule. Basically, we found what visualized the power rule. So in conclusion, what have we done today? We've reviewed the power rule, the difference quotient, how to solve the power rule algebraically, and visualized x squared and x cubed, the power rule in those two. So finding the derivative visualized. Okay, thank you for watching this video. I appreciate you watching it. If you liked it, please leave a like and comment for future videos and ideas. And if you enjoyed these type of videos, please subscribe to see more videos like these. So, Easy Science out.